This is part 3 of section 5.5. We want to graph this system of inequalities, and these are both nonlinear. So, but we graph them the same way. We're looking for the region that is true for both of these. So we would be looking for the part that is shaded by both. Now, if you notice, neither of these have an equal sign, so these are both going to be dotted. Okay, and both of these are circles. Okay, and if you look at these, if you think about your H and a K, both of these have the same center, because H and K are the same for both of them. So our center on these would be, the H and the K are 0, so the center is 0, 0 for both. Okay, we're just saving ourselves a little bit well, just not having to repeat stuff. Okay, so the difference is the radius, and of course these signs. So for the first one, if I'm doing x squared plus y squared equal to 9, my center is 0, 0, but my radius is the square root of 9, which is 3. So for this one, what I'm going to do is my center is here, right here, and I'm going to count 3 in every direction. Okay, and now connect these with dotted circle. So let's see here, I'll get a dotted circle drawn. Okay, now the answer to this one is going to be either inside the circle or outside the circle. Now you can always test your center with a circle, because your circle never goes through the center unless your radius happens to be 0, and that would just be a point. So that's kind of a silly case. All right, so let's test inside or outside. I'm going to test 0, 0 because it is available and easy. That will give me 0 squared plus 0 squared is less than 9. 0 is less than 9, which is true. So for this circle, I tested 0, 0, and it's true. And since this is inside this circle, my answer right now, just cut off everything outside of the circle. It's no longer an option as a solution for our inequality, our system of inequalities. Okay, my answer is inside of this circle. Now let's try this one. If I'm working with x squared plus y squared equal to 1, I have the same center, 0, 0. My radius would be the square root of 1, which is simply 1. So from this center, I'm going to go out 1 in every direction. Okay, and then connect these with a dotted circle, a smaller dotted circle. Okay. Now our overall answer, because my answer here for this one alone is either inside this circle or outside this circle. If it's inside, then we'll be shading this part because that's the part that's true for both of them. If it's outside, I'll be shading this ring area, donut. Okay. So again, we can test our center, which is 0, 0. That would give me 0 squared plus 0 squared is greater than 1. So 0 is greater than 1, which is false. This is the 0, 0 that we tested is inside the circle. It was false, so that means we need to shade the other side. So we need to shade the outside. So for the black circle, it was this side that got cut out. For the pink circle, the middle got punched out, and our answer is the ring. So everything that ends up, every ordered pair that is in this shaded region, but not including the circles, that's why they're dotted, everything here is a solution. We could plug in any ordered pair here and it would work out. Okay, now for the last example here. You'll notice that we have a lot of inequalities. Now, in general, when you had a system of equations, meaning that you had equal signs here instead of inequality signs, we always have to match the number of variables to the number of equations, or in general, it's not solvable. It's like you're putting too many restrictions on it. And if you think about it, your answer in a system of equations is always going to be the point where they cross. And the more lines you have, or the more things you have, the chances of all of them crossing in one point really diminishes quickly. But with inequalities, it's different. Now, in the real world, where you might see something like this, it would be in manufacturing. This is often used in a process called linear programming, which some of you will encounter in other courses. But real world, if you think manufacturing, you have two things that you can manufacture, but your machines have limits. I mean, you probably can't make 2 million widgets in a day, okay? So you cannot manufacture a negative number of widgets in a day, whatever it is you're creating. So you have some logical restrictions. If you look at these two right here, I cannot make more than 3 of these in a day. My Ys, whatever they are. These are widgets, okay? But I'm also manufacturing thingamajigs, and I have to make at least one of those, but I can't do more than 2 of them in a day. So if you think about it that way, this is where this can make sense. Okay, now our objective is to graph all of these, and wherever they are all shaded, that's part of my answer. So you can think of all of these as cutting off a chunk of the world that is not going to work. So we're going to end up with multiple index cards covering parts up here. Now, I started off down here when I was explaining the logic of it. That's because this is a horizontal line. And these are vertical lines. There's technically 2 of them. Our x value is between 1 and 2. This is a vertical line, x equal 1, and then we have x equal 2, which is another vertical line. And our x values are literally between those. So this is going to be easier to graph. I'm going to start off with this one. If I have y equal to 3, I have a horizontal line through 3. Okay? So if I go to 3, it's always going to be on my y-axis because that's where horizontal lines are. And I'm going to draw a nice horizontal line through here. And I'm going to be as precise as I can be on this. Okay? So on this one, to meet these requirements, it's either going to cut off the top part of this or the bottom part of this. Basically, with this one line, we're cutting off half of our possibilities. So 0, 0 is not through this line, so let's test 0, 0. And if I plug in 0, 0 here, I have 0 is less than or equal to 3, which is true. Okay, so here's 0, 0. It was true, so that means this whole side is true. So I'm shading below. So right now, what this has done is it cut off all of these. All these points up here are no longer a possibility. My answers are now down here, and I know that for certain. Okay. So let's keep going. Let's do these two. Okay, so when I have 1 is less than or x is less than or equal to 2, I have 2 lines here. I have 1 equals x, and I have x equals 2. So these are both vertical lines, and this one's going to go through 1, and this one's going to go through 2. Okay. And they are vertical lines, so let me get those drawn in. Again, I'm going to be as precise as I can be. Okay, and then here. Now you can use a test point here if you want to, but if your x is literally between these, then you're going to be shading literally between these. So I know my answer is here or here. So what I have right now, okay, I know my answers are between these two vertical lines and below this one. So right now, I have reduced my possibilities down to this sort of rectangular shape. I say sort of because it doesn't have a bottom boundary, but roughly that. So I've cut out a lot of possibilities. Okay, so now let's go to our other lines. Okay, so let's do x plus y is equal to 2. Now I'm going to use slope-intercept form here. If I move this over to here, I have y is equal to negative x plus 2. So this means my y-intercept is 2, and my slope is going to be negative 1. Okay, so my y-intercept is 2. My slope is negative 1. So down 1, right 1, down 1, right 1, and so on. Okay. So now I graph these as nicely as I can. Okay. 0, 0 is available, but basically what I have here, remember we've reduced it down to this little rectangular area. Now if I need to shade this side of this line, I'll have reduced it to this, it's technically a trapezoid, or I've made it into this region right here. Okay, so let's test this. I could test 0, 0. That would require that 0 plus 0 be greater than or equal to 2. 0 greater than or equal to 2, that is a false statement. Okay, so concentrating on the red alone, here's 0, 0. It was false, so I need to shade this side. Okay, so what have I reduced it down to? Let's try our index cards again. It's not going to be this side. It is not this side. And then I have here. No, not, I have that one placed wrong. Here and there. Let me slide this one up a little. Okay. So now that's all my possibilities. Just that tiny little region. Now I have one more to check. One more that might cut off part of our solution here. So one more. I'm going to deal with 2x plus y is equal to 6. And again, this is easy to move into slope-intercept form. So subtract 2x from both sides. I get y is equal to negative 2x plus 6. Okay. So my y-intercept is 6. And my slope is negative 2. So let's graph this. Plot a point at 6, 2, 3, 4, 5, 6. And then my slope is negative 2. Down to right 1, down to right 1, and so on. Let's get this graphed. Okay, now we had already reduced our possibility down to that little trapezoid there. Now we either have this little region right here or that tiny little triangle right there. And that's going to be it. So let's test 0, 0. If I plug in 0, 0, so that would give me 2 times 0. Plus 0 is less than or equal to 6. So 0 is less than or equal to 6, which is true. Okay, now our final one here. Here's 0, 0. I've got a lot going on here. So here's 0, 0. It was true, so I need to shade this side of this line. So now for our final cover-ups. It's not here. It's not here. It's not here. Okay, and then it is between those two vertical lines. So I can't adjust anymore.